Hello students, welcome to IMS Gate Academy. In the last small revision session, I started clipping circuits. There I explained how the clipping will be done in the given signal. There I said two types of the clipping circuits. One is said to be diode clipper, second one I said as a transistor clipper. But again in the diode clipper I explained what is series diode clipper. I didn't explain in the last session what is shunt diode clipper. In today's session, just one example I will give based upon the shunt diode clipper. Then after I will enter into clamping circuits. Now we can take shunt diode clipper. Shunt diode clipper. Clipper or clipping circuits, both are same. When we can say the given circuit is shunt diode clipper, if the diode is connected parallel to the load or parallel to the source, we can say it as a shunt diode clipper. The diode is connected in series, I said as a series diode clipper. Here we are going to connect in parallel. So I wish to select the diode in ideal case, I want to give one example based upon the shunt diode clipper. There is a resistor R here connected with AC source. You assume this source is nothing but the voltage source. Here the sine waveform I want to give as an input. Here ideal diode is connected here. There is a resistor. Otherwise I will connect one source still best. I want to connect one source. The reference voltage VR, but I wish to select V0 as an output. Practically here connected resistor parallel to this diode, here connected one diode and source, one load resistance will be connected only, you can see now. For ideal case, I selected voltage across these two terminals only now. Voltage across these two terminals is V0 only now. But I want to draw the shape of the output, how it comes. And also, you must draw yourself how the transfer characteristic curve is to be plotted now. Here I will explain only how to draw the output waveform. The transfer characteristics I explained already in series diode clipper. Based upon that concept, you try to draw it, understand. This voltage I wish to give the name Vi. Suppose Vi is greater than Vr. This input voltage is greater than this Vr. Now the diode is a forward bias or reverse bias, you select, you identify. The p-type material, the line indicates n-type material only. Higher potential is connected to the p-type material, lower potential is connected to the n-type material. Then diode is forward biased. I can say when if Vi is greater than Vr, diode is, it's an ideal diode, diode is forward biased. If the diode is forward biased, it must be replaced by short circuit directly. Wherever you got a diode, there you can short circuit. Is forward biased, the diode is replaced by short circuits. That work is required. I would like to draw the network like this now. I got here the source Vi. This is Vi. Here given resistor R. The diode is shorted. The source of Vr is existing here now. But I wish to select V0 from this terminal. V0 I want to take. V0 equal to Vr only now. V0 is nothing but voltage across these two terminals. That is a Vr. I can say V0 equal to Vr. That is the output voltage is possible when diode is forward biased. In case the diode is reverse biased, what happens you will see now. When the diode will be reverse biased, you will understand. if I give here the negative pulse, that means Vi is less than Vr, that is still good enough. Not negative pulse also. If the Vi is less than Vr, I gave it. If Vi is less than Vr, I have taken here now. Less than Vr means, what is the meaning? Vi is less than Vr. Vi is the lower potential. Vr is the higher potential. Lower potential is given to the p-type material. Higher potential is given to the n-type material. In that case, diode can act as a the diode will be in the reverse bias. The diode is in the reverse bias, it will be replaced by open circuit, I can say now. Here I want to write that point. If Vi is less than Vr, diode is reverse bias. If the diode is reverse bias, it must be replaced by, the diode is replaced by open circuit. Diode is replaced by open circuits. But using these concepts only, problems will be done in clipping circuits. Understand my point now? In this case, how we can draw the diagram? There is a resistor R, and here the diode is open circuited. There is a source, that source I want to put it as it is. Here I got the source, input voltage source we got, that is the sinusoidal waveform, Vi. But I wish to receive V0 across these two terminals, between these two terminals. If it is acting as an open circuit, it doesn't flow any current through the network. No current is going to flow. What current is passing across the resistor means zero only. Zero drop only possible here now. So in between these two terminals, voltage is equal to Vi only. V0 equal to Vi. It doesn't flow any current across the resistor. Drop across the resistor is equal to zero only now. So I can write V0 equal to what? Vi. When diode is forward biased, we got V0 equal to Vr. The diode is a reverse bias, we got V0 equal to Vi. Now I wish to draw the shape of the waveform, how it will be. This is the input, Vi. I want to get V0. This is V0. The Vi here given is sinusoidal waveform. We are giving sinusoidal waveform here now. Like that, input waveform is given. How the shape of the output is possible? There is one Vr, reference voltage we got. There is a positive potential, Vr. The same Vr I want to note on this axis, V0 axis. This is Vr. I have taken line with a dotted lines I have taken here. What is given in the problem? If Vi is greater than Vr, catch my point. If Vi is greater than Vr, this portion is the greater than Vr. This portion is greater than Vr. If Vi is greater than Vr, V0 equal to Vr, we are getting V0 equal to Vr. V0 equal to Vr means V0 equal to Vr. V0 equal to Vr means constant voltage only. In between these 2 points, this is greater than Vr. In between these 2 points, I will get only Vr. Even if the input voltage is increasing after Vr, output voltage is going to remain constant only now. In between these 2 points, I will get Vr. This is Vr. Greater than. If Vi is less than Vr means I gave just now, V0 equal to Vi. Less than Vr, V0 equal to Vi means same waveform is possible. You will get the same waveform here now. This waveform V0 equal to Vi. This portion is a less than Vr. same V naught equal to Vi. V naught equal to Vi means I will get like this now. Less than that portion. Less than means V naught equal to Vi I will get. V naught equal to Vi I will get. But anyhow, finally this portion is clipped. The top portion is clipped only, you can say. Such a way waveform is gained by using the shunt diode clipper. Where we are going to use the shunt diode clipper? Series diode clipper, you got it. In the series diode clipper, we are getting the different waveforms with the change of the sources, with the change of the direction of the diode. The same waveform, if you want to get by some other circuits, means shunt diode clipper only now. The shunt diode clippers are the equivalent circuits of series diode clipper. The same output is available here also now. Understand my point now? Yes, the information regarding the clippers. Based upon these concepts, you can do any questions on the gates. Next one is a clamping circuits. I want to give the clamping circuits. Clamping circuits. What is clamping? Definition of the clamping, we can define clamping like this now. The shifting of the input waveform to the required reference level. Required reference level means it will be shifted to the positive side. Otherwise, it will be shifted to the negative side only now. We are not going to find positive and negative only now. Shifting will be done to the positive level or negative level. That's why we can define like this now. The shifting of input waveform, the shifting of input waveform to the reference level, to the reference level, reference level is called clamping, is called clamping. So we can define clamping like this now. Clamping, I can say. Clamping. The circuit which does this operation is nothing but the clamping circuits. How the design of the clamping circuit is to be made? What are the elements are required? The elements which are required in the clamping circuits are one diode, one capacitor, one resistor. But in our gate level problems, we cannot find any resistor. He is going to give the capacitor with diode. Then clamping, what now, is achieved only, you can say now. But here the point I wish to say, the clamping circuits are practically designed by using the diode and also capacitor and resistor only now. Understand my point now? But here, without resistor only, we are going to do only now. But anyhow, how many types of clamping circuits are there? There are two types of the clamping circuits. One is said to be positive clamping, second one is said to be negative clamping only. Like that, two types are there now. First, we can start negative clamping, then after I will go to positive clamping only now. How many types of clamping circuits means we can write there are two types of clamping circuits. Clamping circuits. First one is said to be negative clamping. Negative. If you follow this clamping work, you can do any question. Negative clamping. Second one is said to be positive clamping. Positive clamping. Like that, two types of clamping circuits are there now. Initially, I wish to take negative clamping. First, systematically, I will explain how the negative clamping is done. Then after, very directly, in one step, how to get answer, I will explain also now. Both methods you can understand clearly, understand now. I wish to take initially negative clamping. negative clamping. In the negative clamping, the circuit is designed like this. There is a resistor, initially capacitor is required. It is a clamping work. The clamping, you need to put capacitor initially. Then after I connected one diode, this diode is an ideal diode. I selected ideal diode. In between these two terminals, I wish to connect AC source. This is VI. I wish to get V0 across these two terminals. Across the diode, I want to get V0. This is capacitance, this is the capacitor. How the shape of the waveform? But initially what I wish to say, the VI is the sinusoidal waveform. How that waveform is there, that I want to give in your hand. The VI is the input waveform. That input waveform is given in this form, VI and T. This is a sinusoidal waveform, I said now. That waveform is like this. Constant amplitude only now. You know very well, time taken for the one cycle is said to be time period. You know very well. So this time period is a T. The time taken for one cycle is said to be time period. But to reach to the maximum level, to reach to the maximum voltage or maximum voltage, to reach to the maximum, this is a Vm value. This is Vm. This I want to take it as a minus Vm. To reach to the peak voltage, what time period is required? The time period here required is T by 4. For one cycle, T. For half cycle, T by 2. Quarter cycle here now. Quarter cycle means T by 4. At this point, time period is a T by 4. This is a T by 4 only now. So here the T I can, by using the what T is less than or equal to T by 4, how the circuit is going to operate. If T is greater than T by 4, how the circuit is going to work. Those 2 points we can discuss here now. Once we follow those 2 points, you can draw the shape of the output waveform. Initially, I want to take like this now. When T is less than or equal to T by 4, that time I have taken now. When T is less than or equal to T by 4 means from this point to this point, input voltage is increasing. Slowly it is rising. When input voltage is increasing, diode is forward biased or reverse biased, you try to identify. Here, the diode is forward biased. The reason is input voltage is increasing. When it is increasing, diode will be forward biased. Once the diode is a forward bias, it must be replaced by a short circuit because it is an ideal diode. At the time what V0 is available, you take it now. I say when T is less than or equal to T by 4, diode is forward bias. If diode is forward bias, it must be replaced. It must be replaced by short circuit. By short circuit only. Directly this diode is a short circuited only. I will draw that, you can understand clearly. Here I have taken this circuit like this now. There is a source. That source is given Vi. Input is a source Vi. The capacitor we have here now, that is existing as it is. This diode is shorted here now. The diode is short circuited. Can you say what V0 I can get in between these two terminals? I will not get any voltage. That becomes 0 voltage only now. So I can say V0 equal to 0 voltage. V0 equal to 0 voltage only. What about voltage across the capacitor? Voltage across the capacitor means Vi is increasing from the 0 level. and finally it reaches to the maximum voltage only. When the capacitor starts charging means when the diode is forward bias, then only what is going to happen? The charging of the capacitor is done. So here slowly it is going to rise with a polarity of plus and minus, positively increasing, plus because the induction you will get the negative sign only now. The voltage across this capacitor is to be taken as a Vm. Maximum voltage is going to be formed here now. During the period of the time 0 to t by 4, this work is done. Up to that period of the time, we are finding only 0 voltage only now. In case when t is, I selected here, when t is greater than t by 4, greater than t by 4 means what is going to happen? Diode is a forward bias or reverse bias. You please check it now. You can understand. Already this capacitor is with maximum voltage. Maximum voltage only now. Diode we got. Here the Vi is, the maximum voltage is existing across the capacitor. After Vm, we are finding the what now? Input voltage less than Vm only now. This voltage is less than Vm only possible. If Vi is a less than Vm, this node voltage can make the diode to come to the on state or off state. Vi is less than Vm. At the time, Vi minus Vm equal to what now? This node voltage. This node voltage, we are going to get the negative potential only now. Because Vi is a lower potential. This is the maximum voltage. Vi minus Vc is nothing but the less than negative voltage only possible. When the negative potential is given to the what now? Anode, zero potential is given to the cathode, diode comes to off state. It doesn't conduct. We cannot find the conduction of the diode only now. When diode is not conducting, we can say it must be replaced by open circuit only now. I can redraw this network. You can understand clearly now. I say that in the network, when Vi is, I want to note down here now. When Vi is, I want to note down when Vi. When t is greater than t by 4, diode is reverse bias. Diode is reverse bias. If the diode is reverse bias, it must be replaced by open circuit. It must be replaced. It must be means diode must be replaced by open circuit. Replaced by open circuit. By open circuits. At the time, how we can draw this network? We got here the source Vi. The source we got Vi. There is a capacitor. Already this capacitor is charged with maximum voltage, Vm. This is the maximum voltage. The capacitor is replaced by open circuit. But I want to find this voltage, how much I can get. This is V0. Based upon this V0, I can draw the shape of the output waveform when t is greater than t by 4. V0 is nothing but Vi minus Vm. When it is acting as an open circuit, it doesn't flow current, but voltage is existing in between these two terminals. That V0 is nothing but Vi minus Vm I can put here now. By using this equation, I can draw the shape of the output waveform. I will give the input waveform and I will draw the waveform, output waveform also. You will get clear idea. I am giving the input and output here. This is Vi. This is the T. But I want to get V0. This is T. This is V0. Input Vi, I said already, sinusoidal waveform. How this sinusoidal waveform is to be plotted here? This I can draw like this. The input given is sinusoidal waveform. such a shape of input is given here now. This is minus Vm. This is plus Vm, you know very well. This is nothing but the maximum I got, T equal to T by 4. But how the shape of the output is available? You watch. But already I gave when I will draw the now. I gave already here now. When V naught equal to 0 voltage I am getting now. V naught equal to 0 voltage I got. When I got V0 equal to V naught equal to 0 voltage, when T is less than or equal to T by 4. So less than or equal to T by 4, less than or equal to T by 4, the output is 0 voltage only. Yes, I can draw 0 voltage. Up to this extent. After T by 4, how to draw the output? After T by 4, I said V naught equal to what? V naught equal to, I said, Vi minus Vm, I said, after this point. So suppose this point I have taken now. Vi equal to 0 voltage. If the Vi is a 0 voltage, V naught equal to minus Vm. At this point, I can get minus Vm value. This voltage is minus Vm. Vi equal to minus Vm is possible. Vi is 0. If I selected this point, Vi equal to minus Vm, Vi equal to minus Vm, minus Vm, minus Vm, minus 2 Vm is possible at this point. I will get minus 2 Vm here. This voltage is minus 2 Vm. When you are reaching to this point, Vi is a 0 voltage. 0 minus Vm, I can get here now. This is minus Vm. If I reach to the maximum voltage, Vi equal to Vm here now. Vi equal to Vm, Vm minus Vm, 0 voltage I can get here now. This voltage is going to be 0 voltage. The same thing is repeated. 0 means minus Vm here, minus Vm. Minus Vm means minus 2 Vm, just now I gave it, minus 2 Vm. 0 means minus Vm is possible here, and a Vm means I will get the 0 voltage. Like that it goes. You combine all these points and get the shape of the output. Just now I explained the clamping work is what? I explained very beginning. It is for shifting the input waveform to the reference level, I said now. That reference level may be a positive or negative only now. Here, this will be shifted. How the diode connection is made, you please watch once. You please watch once the diode connection. The diode is connected to the down, arrow is connected to the down only now. The arrow symbol, if it is specified in the down side, you think it's so, downward direction. At the time, the shifting will be done to the lower level only now. It goes to the down only now. If the diode is connected in the reverse, top indicates the shifting of the waveform is to be made just above the what now? 0 level only possible now. Here the point what you have to understand here is how it is done. This portion from here to here, this point to this point, I am going to get the 0 voltage only. From this point onwards, it is shifted only. This portion is shifted. This portion will be shifted. Same shape of the waveform will be shifted to the down. But again, same shape, this shape will be shifted to the down only now. I can draw like this now. This point onward, shifting same shape, it comes only now. By using the graph sheet, if you plotted exactly same shape, you will get now. Same shape you will get now. Again, from this point onwards, again shifting here now. Like that, shifting will be done. This is the shape of the output is possible by using the negative clamping only. Negative side it is a clamped. Negative side it is clamped only now. If it is what, if it, the waveform goes to the top means positive clamping is achieved only. Anyhow, you followed how to get the negative clamping. Suppose any student said, in the GATE exam, suppose this network is given, draw the output waveform means no need to do all these works. Very directly you can do. How we can do? Just please watch. I will explain now. How directly we can get the answer means, suppose you are given here the capacitor, the same circuit I am drawing once again. There is a diode in this direction. Here the waveform is given here now. This is a sinusoidal waveform, Vi. This is a V0. Suppose I asked the output waveform for the given circuit is dash, 4 options are given. How we can draw? Just you please watch. The Vi is a sinusoidal waveform. Systematically I did initially. Now directly I want to draw the shape of the output. The given waveform is this. Just now I said, diode is what now? Direction is a down. Down means it must be shifted to down only. 0 to Vm, you know very well. Output will be 0 only. Why, sir? But in the clamping circuit, how the work is done? Initially, diode will be forward bias. Initially, diode will be forward bias. Then after, diode will be reverse bias. Based upon these 2 points only, the total work will be done. Initially, what I said here now, initially, why the diode must be forward bias initially? We need to charge the capacitor. The capacitor is not charged, I cannot understand what voltage is existing across the capacitor. Then I cannot determine V0 value. That is why initially the diode must be forward bias. Then only we can find the voltage across the capacitor. Next point, what you have to understand, the diode must be reverse bias in the second case only. When the diode is a reverse bias, then V0 I can determine, because already we know the capacitor voltage only now. That is why I am saying here now, first initially the diode must be forward bias, next it must be reverse bias. Based upon that concept only, the clamping work is done. Here, the shifting will be done from, I said already, shifting is done from this point to this point, I said. Again, shifting is done this now. I can draw up to this extent, 0 voltage, I said already. Up to this extent, you can find the shape like this, the same shape. Again, the same waveform, it comes like this now. Like that, up to this extent, you will get now. This is the clamping waveform. We are getting the negative clamping. But in the positive clamping, just I will give the circuit, directly I will draw the output waveform. I am not going to explain anything, because you followed how the working principle of this clamping circuit will be done, you could understand. Now you watch, one more question I am giving now, positive clamping, I want to give in your hand. Positive clamping. Positive clamping. When you want to get the negative clamping means what I said, initially we are getting the positive pulse only now. Here you please watch. There is a capacitor, but I connected an ideal diode in the reverse direction like this. I connected in this way. I wish to get V0 across these two terminals. Input given in the network is Vi. Input given in the network is Vi. That Vi must be, I have taken sinusoidal. Sir, only sinusoidal is applicable? No, you can use square waveform. Otherwise, they want any waveform you can give, no problem. Clamping you will get it now. The Vi I want to take in this way. How that waveform? Just now I said initially diode must be forward bias. If it is to be forward bias, you need to give initially positive pulse or negative pulse. You think it. Positive pulse if I gave, directly reverse bias is possible. We should not give any positive pulse. What pulse I have to give then, sir? Negative pulse you have to give. Once you are giving the negative pulse initially, then only diode will come to the what now on state. Next it comes to the reverse biasing only now. That's why input waveform which is to be given for this network is negative pulse initially, next a positive pulse. Like that we are going to give input waveform. This voltage is minus Vm. I want to take this voltage as a plus Vm. How the shape of the outputs? Directly I want to plot. I said already up to Vm, minus Vm or plus Vm, no problem. Output voltage will be 0 voltage only. Why 0 voltage means I explained. If you are giving the negative pulse 0 to minus Vm, at the time diode is short circuited because it is a forward bias. If it is short circuited, V0 becomes 0 voltage only. There's a up to minus Vm 0 voltage we can find. Then after reverse bias, same shape of waveform I can get here now, from here to here. And again same shape I can get from here to here only now. I want to draw like this now, this form to this level up to this extent. From this point to this point again I will get the shape like this. Like that it goes. Final output waveform will be like that only now. Mr. White King. Such a way the shape of the output will be drawn only now. This is positive clamping. Just I want to give how the gate questions are asked based upon this concept. Just I will give. Suppose you are given one network in this way. There is a capacitor. There is a capacitor here. That capacitor is given C. I connected here one diode. I connected one diode. And one more capacitor I connected here. C, same capacitor. The diode I connected in this direction. The next one more capacitor I connected here. I connected diode in this direction. You can connect any number of diodes and any number of the capacitor. And how to find out how the questions are asked in the gate I will explain now. This is Vi. The Vi is given here. Vi is given a sinusoidal waveform. I will give. This is Vi. This is Vi. That Vi is given in this form. This is a sinusoidal waveform. This is a Vi. This voltage is given 5 volts. This minus Vm is given minus 5 volts. Suppose you are asked in the gate question like this now. You find out the voltage in between these two terminals. This is the V0. I want to select V0 from here. I want voltage in between these 2 points. But how we can find this V0? In a simple way I will explain. Everybody can understand easily now. If I connected the Vi here now, what is going to happen now? The first capacitor, but always remember, the first capacitor will be charged maximum voltage. But before that, you give the polarities also to the capacitors only now. How I can give the polarities are? If you are giving the positive pulse, this capacitor will get the positive polarity. Because of the induction, you will get the negative polarity this side. You go this side, diode will go. This will get the positive polarity because of induction, negative polarity. But again, diode direction, in the direction of the diode you go, this side plus, because of the induction you will get the plus. 3 diodes and 3 capacitors, we got it here now. What about the voltage across the capacitor? That is more important. Voltage across the capacitor I can get when the input voltage is given like this now, slowly, first diode is on and voltage is slowly increasing and reaches to the maximum voltage. Reaches to maximum voltage. There's a first capacitor can have voltage of Vm, must only now, directly you can put now. The rest of capacitor, second capacitor wherever you are having, that will receive peak to peak voltage across the peak to peak voltage only now. Input is given waveform like this now. Voltage across the second or third or fourth or fifth, whatever the number of capacitors are given, the voltage across the capacitor is peak to peak only now. The first capacitor is with Vm, the rest of capacitors with 2 Vm only now. Vm minus of minus Vm, 2 Vm totally. This is 2 Vm. Even you have taken the third capacitor, you will get the 2 Vm only. Even the next one more capacitor, 2 Vm only now. Sir, why I cannot get 3 Vm here, sir, now? 3 Vm impossible, voltage across the capacitor. Why, sir? The diode here we connected here now. The diode is not acting as a rectifier. The diode is not acting as a, diode is acting as a, the diode is acting as an amplifier, you think it's so. The diode is acting as an amplifier. Then output voltage across the capacitor is more than the level of the input voltage only. More than the level of the input voltage only now. But the input voltage is the maximum voltage. What maximum voltage I can get? 2 Vm only now, peak to peak. I cannot get more than that. If I get more than that value, means diode is acting as an amplifier. Diode is not acting as an amplifier. It is acting as a switching element only now. Understand? It is for rectifier. It is acting as a rectifier. It is acting as a clipping circuit. It is acting as a clamping circuit only now. Even in the designing of the filters, we are going to use what? This diode only here now. So anyhow, 2 Vm, 2 Vm, 2 Vm is possible. So voltage across the capacitor will not cross 2 Vm here now. So I want to get voltage from here to here. That is V naught. When I apply the KVL from this point to this point, plus Vm here. When I go this side, plus 2 Vm here. Vm plus 2 Vm is nothing but a 3 Vm I can get here now. V naught is nothing but 3 Vm only possibles. There is a 3 Vm only. So voltage across the capacitor will not cross peak to peak voltage. The total voltage from one point to the other point, if it is taken, may be chance to get more than the what now input voltage only, more than the peak to peak voltage. From this summation of the voltage possible more than 2 Vm also. Across the capacitor will not cross 2 Vm. That point is very important here now. So this circuit can also be said as a what? But this circuit can also be said as a voltage multiplier only now. Voltage multiplication. Suppose anybody wants to get the what now? Voltage of the more and more and more you think it's so. Number of capacitors, number of diodes are connected. Hundreds of the capacitors, hundreds of the diodes you can connect in the network. If you connect it such a way, the output voltage we can increase only, you can say. The cost is not important, sir. How many number of the diodes we are using, how many number of the capacitors we are using in the network is not important. I want to get output voltage of the more means we can connect any number of the diodes and any number of the capacitors to increase the voltage only now. Understand now? Such a way V naught we can get. But this circuit can be said as a what now? Voltage tribular circuit only. Why it is a voltage tribular? 3 times voltage is increased. Summation possible more. But voltage across a single capacitor will not be increasing more than 2 Vm, I said now. So now finally what V naught I can get from this circuit? 3 into Vm. Maximum voltage is a 5. 3 into 5. I will get 15 voltage from this network. Such a way gate questions, whatever the number of diodes are given, whatever the number of capacitors are given in the gate questions, you can do by the same process and you can get the output voltage only now. I hope you followed. This is the clamping process only we can say. Next I want to explain the Zener diode also. Zener diode. The Zener diode, but I am using Zener diodes asking gate questions also. So I will do the analysis how it is to be done. To do some analysis I will do. Based upon that you can do any question, any problem you can do very easily now. Understand here now. Zener diode is mostly used for the regulation of the output voltage. The input voltage is what now some higher potential you are giving, but a required output is a lower you think it's now. At the time you can use the Zener diode circuits only now. Sir, I suppose the input voltage is a very high, still more higher you got you think it's so. Regulation is to be achieved. Only with a Zener you cannot regulate. Zener with a transistor they will design. If the input voltage is still higher, very higher you got, I want to regulate the output voltage. It is designed Zener with the transistors in operational amplifiers only now. By using the op amp, you can regulate only. Let's say there it is implemented GNR with transistors only now. Anyhow, the GNR diode symbol we are going to use like this. It's like a Z. We can put this now. GNR symbol only now. But how to do the problems? What work you have to understand? That is very important now. I will explain. Voltage across the GNR, I will put VZ. This is a symbol I can say. But I am not going to explain how the working is done. All this is not required now. But in the regulation, how it is working, that is very important. The gate or engineering service instead. Suppose I gave one of the circuit is a type 1 circuit. I will put, for example, type 1. There is one resistor, and I connected one GNR diode here. There is one GNR diode. Here connected with a voltage source. This is a VI is the input voltage. I want to connect here the load. This is the load resistance I connected here now. But I want to take voltage across RL as a V naught. This is the V naught value. The voltage across GNR I want to take it as a VZ only now. The GATE exam you will find type 1 circuit like this. Type 2 means load is variable. Type 3 RL is constant, R is variable. Type 4 VI is variable, R constant, RL constant. Like that 4 models of the circuits you can find. If you follow those 4 models, you can do any question. First, R, RL, VI are fixed. All are fixed values only now. Now try to understand. Suppose you are given VZ equal to some voltage. VZ is given 5 voltage for example. R is given, VI is given, RL is given. Is asking to find the V naught value. What V naught is possible? If VZ equal to 5 voltage, anybody can say what V naught you can get from the given circuit. I am asking, any student can give answer. If GNR voltage is 5 voltage, I am asking, can you say what is V naught for the given supply? Supply may be any voltage. Directly we cannot say, sir, V naught equal to VZ only, sir. V naught equal to VZ only now. The students will say, sir, here the RL and this GNR is parallel to the what now? RL, sir, now. At the time, V naught is always maintained VZ, sir. No, it's not so. But if based upon the design of the circuits, based upon the what now given input, based upon the currents and voltages now, V naught equal to VZ possible, otherwise V naught is not equal to VZ. Only 2 cases possible here now. V naught is equal to VZ possible. V naught equal to VZ you got means the circuit is perfectly working as a regulator only now. If you are getting the what now, V naught is the less than VZ if you got, it is not a regulator circuit. Practically such a type of circuit is not acceptable now. But in the GATE exam you will give like this, you will ask to find out the V naught. At the time what you have to do, initially you must make an assumption. The GNR diode is in off state. That is very important. There is no breakdown across the GNR diode. That is the first assumption you must make initially. The circuit is given like this. If there is no breakdown, there is no breakdown across the what? No, GNR diode. If there is no breakdown means what is the meaning? GNR is not on conduction state only now. The GNR is in the non-conducting state only now. If it is in the non-conducting state, it must be replaced by open circuit only now. GNR is not on because there is no breakdown. At the time, GNR diode is replaced by open circuit. Same work required in the problems. But here it is a open circuit. I connected here source VI. This is the VI I kept. Resistance R is existing that I placed as is. GNR is open circuited here now. The load is to be connected as is. Load must be taken as is only now. The voltage across this RL is to be taken as a V naught value. You must find V naught at first from the given problem. How we can find V naught? If the GNR is not on state, not in conduction, V naught we can find by using the voltage divider formula. How we can apply voltage divider formula? V naught equal to supply voltage VI into RL by R plus RL. By using this formula, you are going to get the V naught value. Based upon that V naught value, you will come to the conclusion V naught equal to Vz or V naught equal to less than Vz. You can understand. Suppose Vi is given, RL is given, R is given, V naught I calculated now. Suppose I got V naught equal to some voltage. Vx I have taken that voltage. Suppose that Vx is less than Vz, you think it's so. What V naught I got is less than Vz only. This is a 5 voltage Vz. I got V naught as a 4 voltage only. 4 voltage means what happened now? This node voltage is same 4 voltage. At 4 voltage, there is no breakdown. Our assumption is correct. What assumption? Diode is off. This is correct only because V naught is less than Vz value. Less than Vz, whenever you are getting, you must take V naught equal to Vx only. V naught equal to Vz is not allowed. V naught equal to Vx only allowed. When? If V naught is less than Vz only now. In case you are getting, if V naught is equal to Vx, that Vx is greater than or equal to Vz you are getting. The output volt Vx, this one, I will put as a Vx. I am getting here now V naught equal to Vx I got, that Vx value is a greater than or equal to Vz value. In that case, V naught will not go beyond the level of the Vz. It will not go beyond the level of the Vz, parallel condition. In the parallel condition, less than Vz possible, more than Vz is impossible. We cannot find such case only now. That's why you can write, if V naught equal to Vx, that is a greater than Vz. If you got, you think it's so. You can write directly V naught equal to Vz only. Greater than or equal to Vz, if you got, V naught must be taken as a Vz only now. Based upon this concept, you need to find what V naught is possible from the given circuit. Once you are getting the V naught value, you think it's so. In the gate questions, you can find different currents also. Suppose you are asked in the gate, you find this current. Otherwise, you will ask to find out the Zener current. You will ask to find out the load current only. By using the Ohm's law, you can find all the remaining currents only. It doesn't take more time. You take as an example R and RL values to substitute, Vz equal to something you put, Vi equal to some voltage you give it, and start doing by the same process. 100% you can do very easily now. I hope you followed so far. Thank you.